Hi class. In this discussion I'd like to show you how you can use Microsoft Excel to calculate binomial problems so as to, let's say, answer the problems that are in chapter 5 of your text. To get started, let me just first say a couple things about Excel as opposed to SPSS. Can you do this in SPSS? The answer is yes, and as a matter of fact there is a tutorial in the content section of D2L that will explain how you can actually do the binomial calculations in SPSS. But frankly, since we're just doing basic calculations, it's much easier to use Excel as opposed to SPSS. In fact, I would recommend using Excel. At the end of the day, of course, it's your own choice how you want to go about doing the calculations. But like I said, I'd recommend Excel. In other words, the idea being is use SPSS if you have to crunch or massage a lot of data. Use Excel if you just have to do some basic calculations. Anyways, to get started, let's take a look at this template that I have set up here. You'll notice in column A, row 1, I have n. N is going to be, we're going to find out that n is going to be the sample size or the number of trials. In column B, we have P. P is the probability of a success. In column C, we have X. X is the number of successes. Now, you'll also notice that in columns D, E, and F, I have three different types of probabilities. I have in P of X is the probability of exactly X successes. P of less than or equal to X is the cumulative probability. In other words, the probability of X or fewer successes. In other words, the probability that you have anywhere between 0 and X successes. And then P greater than X, which is 1 minus the cumulative probability. In other words, the probability of more than X successes. So to demonstrate how to use this template, I'm going to work with problem number 36 in the text, and problem number 36 can be found on page 209 of the text. And the question reads as follows. According to a survey conducted by TD Ameritrade, 1 out of 4 investors have exchange traded funds in their portfolio. For a sample of 20 investors, answer the following questions. Okay, so what do we know? We know we're going to have a sample of size n, or you can say n is the number of trials. We're going to have 20 trials. And we know that the probability of a success is going to be, P is the probability of a success, and we know that's going to be 1 out of 4, or 0.25. X is the number of successes. So if we take a look at 36A, compute the probability that exactly 4 investors have exchange traded funds in their portfolio. So we're going to let X equal 4. So now the issue is to find out what the probability of 4 successes is. So what I'm going to do is for P of X, we know I'm going to be working with what's called the binomial distribution, and that's binom in Excel .dist. So that's what I'm going to use. And you'll notice that there's, you can see what the argument is. Number underscore S is the number of successes. That's 4. And that's what we're going to find in cells, what is that, C2, comma. And then the number of trials, that's N. And that's what's the information in cell, what is that, A2. And the probability underscore S is the probability of successes. And that information is in cell B2. Now the next argument, the final argument, is cumulative. Since we're only interested in an exact distribution, I'm just going to put 0, or I guess you can also use false, but I'll just put 0 here to let Excel know I'm just looking for the probability of exactly 4 successes. And the answer here is 0.1896. Is 0.189. Now it probably makes sense to probably take this down to round this up to maybe into the thousands. So I'm gonna truncate this a little bit. So the answer is 0.190 if you go out to 3 digits, or 3 places to the right of the decimal sign. Now, just for the sake of argument, suppose we also want to know what the cumulative probability was. And again, it would be the same idea. We do binomial distribution. And the same as before, The number of successes is 4. The number of trials is 20, which is the information in cell A2. The probability of a success, again, can be found in cell B2, which is 0.25. This time, though, for cumulative, I'm going to type 1, or you can also type true, and I'll hit return. And again, what I want to do is to take this down to just 3 decimal places to the right. Here, what I'm going to do is I'm going to go up here and do copy format and impose that here. And so the answer is 0.415. Finally, if we want to know what is the probability of getting more than x successes, remember we're working with a discrete distribution, that means the probability of 5 or more successes, right? So the probability that x is greater than 4 is the same as the probability of 5 or more successes, and that's simply just equal to 1 minus the cumulative distribution, which is 1 minus the probability that x is less than or equal to 4. And I'll hit return, and the answer is 0.585. All right, so let's do a couple more problems. Let's do parts B, C, and D. Compute the probability that at least 2 of the investors have exchanged traded funds in their portfolio. At least. Now, that's the crucial word here. So if we're talking about at least 2 or more, that's the probability that x is greater than or equal to 2, which is the same as saying is the probability that x is greater than 1. So what I'm going to do here is for x, I'm just going to type in 1 and hit return. And the answer should be 0.976. Let's do C. If you found that exactly 12 of the investors have exchange traded funds in their portfolio, would you doubt the accuracy of the result? Okay, so let's look at this question again. If you found that exactly 12 of the investors have exchange traded funds in their portfolio, would you doubt the accuracy of the results? Okay, so what is the probability of having 12, exactly 12? All right, here we find that the answer is basically there's only a 1 out of 1,000 chance that possibility can exist. In other words, so that means this is a highly unlikely event, which means we would doubt the likelihood. In fact, if we go back here and we see, maybe it's even, yeah, it's like, 8 out of 10,000 or 75 out of 100,000 chance. There's only like a 75 out of 100,000 chance that could really happen. So it's a very highly unlikely event. All right, let's do 36D. Compute the expected number of investors who have exchanged traded funds in their portfolio. All right, now to answer that, you'll notice that in column A, rows 5, 6, and 7, I have the expected value of x, the variance of x, and the standard deviation of x. Well, the expected value of x is equal to the number of trials, or the sample size, times the probability of a success. Now, the number of trials can be found in cell A2 times the probability of a success, which can be found in cell B2. The variance of x, even though the question is not asking for it, we can answer that as well. The variance of x is equal to what? The trial size, the trial size times the probability of a success times the probability of a failure, and recall with the binomial distribution, the probability of a failure is 1 minus the probability of a success. And the standard deviation is simply just the square root of your variance. And again, let's take this down to just 3 decimal places to the right. 3 places to the right of the decimal, and that's 1.936. Okay, so what I've shown you is basically how you can create a template in Excel to be able to answer the type of binomial distribution problems that you see in your textbook. One last thing, if you're interested in taking a look at the formulas, let me just put this into formula view. And you can also get an idea, let me just clean this up a little bit, and you can get an idea of what the formulas look like. And so what you see before you are the actual formulas for calculating these probabilities.